Hello viewers, this is Arun Mampari on behalf of Swarajya. Semiconductor chips have been a talking point over the last few months, and there is a question of will India manufacture semiconductor chips? Before I talk about a panel discussion, let me take you briefly through an overview of the semiconductor chip ecosystem. As you can see, the middle portion, there is research involved, design of the chips involved, manufacturing, assembly, testing, packaging, and distribution. And these are supported by various kinds of suppliers like raw materials, equipment, electronic design automation for design companies, as well as IP companies. The manufacturing segment itself has predominantly two models, the foundry model and the IDM model. And you can see the kind of companies globally that are involved listed here, not necessarily in the order of their market share. For example, among the fabless companies, there's Qualcomm, AMD, MediaTek, and so on. Among the pure play foundries, there's Global Foundries, TSMC, SMIC, Tower Jazz, and so on. For the semiconductor assembly and testing, there are companies like Amkor, ASC. And in the IDM model, you see companies like Intel, Samsung, Texas Instruments, and so on listed. Samsung is a peculiar case because it also offers foundry for third parties and has a good market share there as well. Now, there has possibly been a common misconception that there is only one equipment manufacturer for the semiconductor fabs, which is not true. So I just put one chart showing the top 10 semiconductor equipment suppliers. We might not cover the display fabs in detail, but I just wanted to also mention that there are also display equipment suppliers. Now, when you talk about electronics, there is a market number for the electronic gadgets as such. And if you take the 2020 numbers, Apple tops with about $260 billion, and Samsung comes second with a little over $200 billion. Now, the semiconductor that goes into these electronic materials, which are predominantly the ICs or the chips, form a different market, which for the year 2020 added up to about $450 billion, for which Intel topped and Samsung came second. You will notice that in this list, TSMC is third. So where is TSMC the top and occupying 54% of market share? That is in the foundry segment or the contract chip manufacturing segment, where again Samsung comes second. UMC is now third, Global Foundries fourth, SMIC fifth, and a bunch of players like Tower Semi, HS Grace, PSMC, and so on follow. What is India doing? On 15th of December 2021, the cabinet approved over $10 billion as incentives for predominantly 4 buckets of initiatives. The aim is to have at least 2 silicon-based fabs, at least 2 display fabs, at least 15 in the category of compound semiconductor fabs, silicon photonics fab, sensor fabs including MEMS, as well as ATMP or OSAT units. About 100 domestic design companies will also be supported through a design linked incentive scheme. And for each of these buckets, the incentive announced is also mentioned here. The official press release also had a mention of attempts to modernize SEL through a joint venture with a private firm, as well as setting up an India semiconductor mission, which will see through all these efforts. A lot of things, a lot of questions are probably still not clear, and hopefully, we will see more details of this coming out in early 2022. We will wait for those. In the meantime, we have a panel of experts from both the West, the East, as well as India, covering various domains of expertise, discussing the opportunities and challenges in this new journey that India has undertaken.
We are live. Arunji, you can go ahead. We are live actually.
Hello viewers and namaste. A very good evening or a good morning to each and every one of the viewers and welcome you all. I am Arun Mampari, joined also by Manohar Sitaram and a team of Swarajya members making this happen. I would also like to welcome all the panelists today to this event who will be introduced soon. I just want to add that some of the questions that the viewers had contributed through a Google form, as well as what you can contribute right now through the YouTube chat, will be passed on to me towards the end of the event, and selected ones, hopefully within the time limit that we have, we'll try to address them. Without much further delay, let me start to introduce our distinguished panelists. I will start with Professor Subbu Iyer. He's professor at UCLA and is director of the UCLA Center for Heterogeneous Integration and Performance Scaling, focusing on packaging new architecture and novel devices. He teaches courses on device physics, process integration, packaging, and circuit designs. His 30-year career at IBM included the development of the first SIGI-based HBT, SOI wafers, embedded DRAM, eFuses, and 3D integration. He was responsible for developing the 45 nanometer CMOS node at IBM, and this technology was used by Samsung, a JDA partner, to build the first truly low power processors for the first generation iPhone, iPad, and Galaxy phones. Professor Subbu transferred and shepherded all his development activity at IBM into manufacturing and initial product introduction. He has strong connections with IIT Bombay and IISc Bangalore and is anxious to see India achieve a degree of self-reliance in microelectronics. Welcome, Professor Subbu Iyer.
Thank you so much, Arun.
Nisha Holla writes on ideas and shifts at the intersection of technology, economics, and policy. She is Technology Fellow at CCAMP and Visiting Fellow at ORF. Nisha's writings have appeared in several leading publications in India, including Swarajya. She has previously worked in hardware product development in the semiconductor area, energy, and biotechnology sectors, both in the US and in India. Welcome, Nisha.
Thank you, Arun. Thank you. Happy to be here.
Mr. Vaidya Bharadwaj is a 25-year veteran in semiconductor, leading edge fab equipment. He started as process engineer in technology development, then moved across technology program management, global marketing, and is now in product marketing. He lived and worked in US, Japan, and US, and have worked with semiconductor manufacturers and technology partners across the globe. He's currently senior director at Tokyo Electronics TEL. Welcome, Vaidya.
Thank you, Arun, and thanks for Swarajya providing me an opportunity.
Mr. Sandeep Arora from the Indian Electronic Semiconductor Association, or the IESA, the premier industry body representing electronics and semiconductor industry, which works closely with the industry as well as the government to bring forward-looking policies and create positive business environment for the industry growth. He has previously spent 20 years at Intel, having joined Intel as the initial of the first team and helped Intel build its presence and business in India over 20 years in various leadership roles. Welcome, Mr. Sandeep.
Thank you. Thanks, everyone. Thanks for having me here. Glad to be here.
So here we start. Hopefully, most of you viewers would have seen a small orientation video that was played at the beginning. If not, you can always go back and watch in the recording. The way we will structure is we'll have a first round of one question each to one of the panelists, followed by a second round where we'll have open questions, which any of the panelists can pick, and of course, the others can add on as well. And then if we have time, we'll add more questions and audience questions. So I would like to start with Nisha. Nisha, in your recent article in ORF and Swarajya, you've spoken about the importance of onshoring fabrication in India. And one of the data points that you quoted is from 2018 about India's electronics goods import being about $56 billion worth, and India's electronics goods production being about $60 billion. Now, two parts to the question. First of all, can you explain what these goods include and what these figures include? And secondly, for these 2018 numbers or an equivalent set of numbers, will you be able to tell us how much of semiconductor or electronic chips, semiconductor chips, had to go in or because of which India had to import them?
Absolutely. Arun, great question. Thank you. And first off, I want to say I'm very happy that the government of India has taken this historic step to, for self-reliance in India in the semiconductor space, and glad to be part of this discussion. And, great question, because I'm always in favor of data-backed policy making. And I think the figures that I give today will help us understand where the Indian semiconductor space needs to go next, right? So as you mentioned, $60 billion worth of production of electronic goods in India in 2018. About a third of that, so $20 billion worth, were mobile phones. That's where India is today the second largest producer of mobile phones today, and you can see that in the data. Another third comes from consumer electronics and industrial electronics. And then you have about $9 billion, so about 1/6 worth coming from electronic components. And the balance is made up of computer hardware, strategic electronics, LEDs, and so on. So there's quite a mix going on here, of which, of course, mobile phones dominate. And after that, electronics for consumer and industrial applications. And that is where India can use this data to focus on, okay, fabs and then next where. So that data is very useful looking at it there. Now, you also asked about imports, and of course, that will have a bearing on where India goes next in the semiconductor space, because out of the 100% of the imports we had, 42% is telecom equipment. 42% is telecommunications, and that communications is becoming more and more important. India has taken strategic steps into 5G and 6G, and where India today has maybe 300, 400 million smartphones, it'll be 1 billion smartphones very soon. And all of them have to onboard into 5G. So this 42% number is very important coming in our imports, and we have to be able to bring self-reliance there as well. Another 20% is in electronic components. And then the balance is made up of hardware and peripherals. You have electronic instruments and consumer electronics. So again, quite a mix going on in our imports as well. And that will also, as I said, have bearing on where we take our fabs and semiconductor chips into. But the most important data point I have today is the IC and the imports of the chips that came in that went into the $60 billion worth of electronic good production. And 2018 is a very interesting inflection point, Arun, because our imports jumped from 2 billion to 8 billion, sorry. So 2 billion in 2017 and 8 billion in 2018. That's a four-fold jump. And that's what drove part of that 60 billion electronic goods production. And you might ask why we had this inflection point. And there are about 3 reasons that I could find in this space. One would be the US-China trade tensions were escalating at that time. And so there was a rebalancing of supply chains. And a lot of companies started relocating into India in the mid-assembly section. And so they started importing more of the ICs to then export these electronic goods. So you started seeing some rebalancing of supply chains that we can take advantage of even today. A lot of these companies were in the telecom space, so you can start seeing how these pieces fit together. The second reason for this inflection point is India started putting increased tariffs on certain finished equipment like mobiles, but not on the components. So companies started importing more of the chips, and so as to not focus on the import duties for the finished product. So that was another and simultaneously you can see the increase in assembly operations in India at that time. And the third, of course, is India was growing into the major mobile market that it is today. And so a lot of companies like Samsung, Xiaomi, Foxconn, of course, started moving into India. And so our IC imports went up simultaneously. So that's the breakdown of the data, Arun. And further down in the discussion, I would love to go into a little more analysis on what these data points mean for India, especially with respect to the government's latest decision to go into fabrication.
Excellent, excellent. Thank you, Nisha. I think if I remember it right, tomorrow is probably Srinivasa Ramanujan's birthday, and numbers have set the base for this discussion. Glad about that. Thank you, and we'll come back to you on further what next, right?
Mm-hmm.
So let me move on to Mr. Sandeep. So let me add on to the previous question. So those were 2018 figures, and now we have the Minister for Electronics and IT, and in general the ministry itself putting out figures that right now the production in India for electronic goods is about $75 billion dollar worth, and the target for 2025 is about $250 billion by conservative means. I mean, some say even $300 billion. So now I have again two parts to the question. What do you think is going to make that possible? Are there enough incentives for the assembly units and so on? And secondly, if these assembly units take off much more big time, won't the import of the chips also substantially go up, given the fact that a fab, even if approved now, will probably going to take 3 or 4 years to come up? Mr.
Thanks,
Sandeep.
Arun. Great question. And I think let me set the context from picking up pointers from what Nisha said. First of all, I think this is a very, very forward-looking policy which Government of India has brought about right now, and much needed. And if you look at the numbers, we can look at conservative numbers or we can look at aggressive numbers, but the numbers are going to go up for sure. Whether it's 250 or 300 in 2025, anybody's guess. Let me step back and tell you a few years ago when we was debating about India's electronic and chip import bill and how it was going to cross our petroleum import bill at one point of time. And while we were making those assumptions, I don't think anyone made a non-linear assumption. We were all making linear assumptions that this is the progression of the business and this is how it will go. But I don't think anyone 5 years ago or 6 years ago envisaged the percentage increase of chips and semiconductors and electronics in general in everything we use. Take cars, for example, automobiles. And, it's a hot topic globally. We are seeing shortages only because of semiconductors. And what we are also seeing is that in the last 5 to 10 years, the percentage of semiconductors or electronics in automobiles has gone up substantially. From a low percentage point, we are at reaching almost a double-digit percentage points. So I think when you start taking that into account, that semiconductors and electronics and chips in general are not a vertical anymore. They are a horizontal. They are the base case for everything. And every industry depends on more and more chips going forward. And I think the demand, we are saying 250 or 300, it might even outpace 300. But having said that, to your point, that there's a 4-year gap in terms of setting up a fab, and then as the fab comes up, what do we do? I think it's a classic chicken and egg story. We can't wait for the perfect moment. these kind of decisions are best done when they are done. I think maybe we are slightly late, but it's a brilliant step taken right now. And I think while we wait for the fab to come up, what we need to do is not just have the fabs being set up, but also build a complete ecosystem around it, so that we build this ecosystem for a very, very long term vision. We focus on skills, we focus on availability of skilled manpower, we focus on supply chain. We need to make sure that our suppliers from India are not only supplying to fabs in India, but to fabs globally. So I think this is an opportunity where this is a great, great impetus given, not just to invite companies to build fabs in India, but to build the entire ecosystem. And I think we'll live with that weight while the fabs come up. But we have plenty of work to be done in those 3 to 4 years, so that as we progress, we make holistic progress and not just go in one direction. Thank you.
Excellent. Thank you. So the word ecosystem, I think, leads to my next question. Professor Subbu Iyer. So I had shown in the introduction also, and if you look at the government press release, it is broadly categorized into four buckets of incentives, or incentivizing four buckets of initiatives. One is silicon fabs, which the government would like to have at least two of them come up, at least two display fabs, at least 15 of either compound semiconductor fabs, or silicon photonics fab, or display assembly units, or the OSAT, and the bucket on the design, about 100 companies to be incentivized. So, what would you think, Professor Subbu, as would be a practical goal to be set in terms of the mix of these initiatives as well as the number of these initiatives? Given that the amount so far announced, the overlay so far announced, is about $10 billion worth of incentives, it could go up. There might be a state government component, we don't know yet, but let's assume $10 billion as the base incentive. And what would be the right mix of these initiatives to come up, these companies to come up, these fabs to come up, in your opinion?
Yeah, so let's first put some realistic sort of numbers here, right? I mean, a semiconductor fab, if one talks about a fab that is, say, building 90 nanometers or 65 nanometers or even 45 nanometer technology, right, will cost about $3 to $4 billion to establish. Okay, if one is to actually develop a technology completely by oneself, okay, that is probably another $2 billion or so dollars. So we must be cognizant that semiconductor technology is not for the faint-hearted. And so while the number of, say, 10 billion or $30 billion sounds like a big number, okay, it is not adequate to meet all these sort of goals that have been set, and some sort of prioritization needs to be made. So let us also understand a couple of other things. One is that semiconductor technology, microelectronic technology, other than sort of assembly, like assembly of phones and things of that sort, other than that problem, that particular aspect of it, is not a big generator of jobs. Okay. In fact, a semiconductor fab has very, very, very few people actually in the fab. There are quite a few sort of software kind of people running the fab through automation and so on. But again, that's not a huge number. So the argument to invest in semiconductors has to be strategic. And I would actually go back and look at what Nishaji mentioned. You know, where are we using the most semiconductors? Where are we most dependent on overseas suppliers of semiconductors? And where could they disrupt our whole system? And clearly, right, the communication area is one that is very, very important. And the other area that I think is pretty important is actually defense. Okay, we cannot be completely dependent on external chips for our defense, especially if those chips are coming from countries that are questionable relationships. So the other big issue that we need to consider while deciding this question, right, that you've asked, is the issue of infrastructure. Semiconductor technology requires a huge infrastructure, and this infrastructure today is in its infancy in India, to be honest. And so that infrastructure needs to be developed. And I believe that the amount of investment that has to be made in this infrastructure actually will be at least 3 to 5 times that of the investment in the fab. I mean, the fab does not exist by itself. Okay, so some of this, of course, can come from private industry, and supply of gases in large quantities of an adequate purity and things of that sort, right? So if you put all this together, right, and you ask yourself, what are the things we can do, then I believe that one has to choose one or two of these four items that you brought about, 4 or 5 items that you brought about, and see which of them makes more sense. So let's first take the easiest one, design. Okay, design exists in India. It is actually quite good, but we have just started to design our own products. So I think incentivizing design resources, incentivizing design companies, starting more design companies, and so on and so forth in India makes a lot of sense. And we can get these chips fabbed anywhere we feel like at this point. Okay, there is a crunch today, but it is not good. The capacities are going to increase, and there will be capacity. So that's a no-brainer. The second thing that you brought about was packaging and OSATs and assembly. That too is actually a very good area that is closer and closer to the system. And as was mentioned earlier, right, we are now one of the largest assemblers of phones in India. And so, taking that one step back to sort of assembling the packages and the PC boards and so on and so forth is obviously a next important step that can be done. The beauty of doing that actually is that the capital investment and infrastructure required to do an ecosystem required to do that is not as onerous as building a fab. So the last question to ask is, hey, if you want to kind of build a semiconductor fab and a display fab, which is more important? And I would say the display market is extremely competitive right now. And there are a lot of new display things that are happening, such as LED displays and so on and so forth, very, very high resolution displays and so on. And I think, we should sort of watch that space carefully before we jump in. But one place that I think is very, very important is the fabrication of communication chips. Okay, and that fortunately does not necessarily require the greatest and the most advanced technology to do. One could actually do a pretty good job of building communication chips, say at the 45 nanometer node, or even an earlier node for the analog and mixed signal parts. And so I would say that if one was to invest in two fabs, one should be a digital or mixed signal, analog digital kind of fab in, say, the 45 nanometer node, or maybe if one wants to be more ambitious, in the 28 nanometer mode, because I think you will get more, you'll be able to buy that technology and not have to develop it yourself. It's reasonably older technology that companies will be willing to license it. I think those. So my recommendation, if anybody asks me, would be to focus on, say, the 28 nanometer node for a fab, and for the moment, do not consider displays, and then focus on sort of the OSAT, or what I would call the packaging part of the technology, and of course the design. I think as time goes on, and if all this looks good, one can think about building some very specialized sort of 3-5 fabs, okay, to build defense related chips that can be in held back by law from advanced countries like the US. I hope that answers your question, Arun.
Yes, definitely. Thanks a lot. A lot of details covered. And I'm sure in the second round, if the other panelists also want to add on their comments to that, we will take those. For now, let me move on to Mr. Vaidya. So, your background with TEL and TEL being among the top equipment suppliers for both semiconductor fabs as well as a segment of the display fabs. What do you think? What do you see happening in India in terms of what kind of fabs might come up? To quote an example, I had interviewed in Swarajya the effort of Tower Semiconductor through its India partner Next Orbit Ventures, proposing a 65 nanometer analog mixed signal, the kind of close to the kind of fab that Professor Subbu also mentioned. But there is also a lot of rumors in the media, or speculation, I should say, in the media of the government of India in talks with TSMC or UMC. It's not clear what technology node it might be, but possibly in the 20s, 20 or 22 or 28. There is also efforts through Quad, Japan, or why not collaborate with Japan for a lot of the raw materials and the equipment that is needed for the fab. So, where do you put all these together, Mr. Vaidya?
Good morning, everyone. Thanks for providing me an opportunity to. This forum actually increases the awareness in India, within India, also on semiconductor. And as Nisha mentioned, and also Sandeep mentioned, there's a tide turning. There's a transition happening within the India now. It's not that it didn't happen 10 years ago or a decade ago or maybe more. It did happen then, but now there's a slightly different reasoning. There's a geopolitical tension. There is also an huge increase in market created by semiconductor itself, not just in India, outside India. So there's a real need for India to move in the manufacturing sector. But as Subbu-san mentioned, the challenges that India has are phenomenal, significant challenges to overcome. Now, as you mentioned, there are 4 sectors that India needs to focus, and each of them feeds into itself. OSAT is a good place to start, and that feeds into the next in terms of semiconductor fab. So the challenge is what we see as a manufacturing, especially as an equipment manufacturer, is can India stomach, like, not just the money. I mean, money is important, but the challenges in terms of infrastructure for 28 nanometer and beyond. Now, we do see there's a possibility for a 45 nanometer fab, even a 28 nanometer fab, because the amount of both in terms of knowledge base and the money required for 28 nanometers is slightly less than, say, if you want to set up a 20 nanometer fab. 20 nanometer fab is exponentially higher, both in terms of money and in terms of even the knowledge base required. So even though it sounds 28 and 20 these are 2 numbers, but significant difference in terms of transition of technology. In fact, 30 to 28 itself, as Subbu-san knows, a significant change in technology. So we do see there is a possibility for India to move to 28. But having said that, as Subbu-san mentioned earlier, $10 billion is not a significant amount at all. It sounds significant for most industries. For a semiconductor, especially a leading edge fab, at $10 billion is not significant at all. In fact, a fab itself probably will cost around, a 28 nanometer fab will probably easily cost around $5 to $6 billion, just the fab itself. But setting up the infrastructure, setting up the ecosystem, having the infrastructure set up for that, water, electricity, most importantly, the skill set in terms of engineering resource. Even though we do not need a lot of engineers, it's not a resource intensive as other manufacturing industries are, but we need highly skilled, highly educated skill set, mostly PhDs and masters. So we would need to spend a lot more right now to build the infrastructure to set up industry, like, say, 5 years from now. Of course, there's always a path for India to do, call back the expats from outside. Maybe Subbu-san can come back to India and lead the development there. But, if you look at what China did, China's semiconductor did not come up in 2018, 2019. They started in 2001, 2000, early 2000s. They failed at least 5, 6 times before they could, they are where they are today. And also the other interesting thing that China mixed in their infrastructure is they did not just focus on logic. I understand, we're all focused on 28 nanometer, 65 nanometer, we're just focused on logic, and we think logic is all semiconductor. No, there is, if you look at the smartphone, of course, CPU is important, but there's also memory in that. And the low-end memory part of the flash memory can be done in India also. So it is also significant in terms of capital intensive, but India should also focus on non-logic chips of silicon for, like Superfan mentioned, in terms of communication chips. Yes, that'll be a easier path segue for India to get into. Beyond that, I think memory, India should look at memory chips. There's nothing like low-end memory, but start at least a base work for that. And also look at this $10 billion is not going to be enough. They need to really, if you look at China, what they're talking about, hundreds of billions of dollars, not just 10, $20 billion. In a year, they're talking about $120 billion. They're setting up like 10 fabs a year. That's significant. So if you want to grow at scale, India doesn't need to grow at scale in terms of, the next 5 years. But if you want to think, you have to think big. The other thing that kind of concerns me is the public. In India, of course, it's tax money. It's a democratic country. So if you spend so much of money, it's not a direct consumer product. If you tell if you talk to the people there and say we're going to invest $100 billion, their immediate concern would be, I need food, I need water. That's more important than providing water to a semiconductor industry. So we need to manage all those nuances in terms of the government. Semiconductor does not impact common man on everyday day-to-day life. They may not know that it does impact, but they may not know that. So educating people on what the impacts of semiconductor, I see, as Supersan said, actually defense. It's a soft impact, but it's huge when you compare the amount of, it's more strategic. Semiconductor is like oil, but people know what oil means. People don't know what semiconductor means. So we need to educate the people of India on semiconductor background so that it's easier for people to support, and also join the industry. So I think that work hasn't been started. Most of us are talking about semiconductor. We know the industry, we know the background. So I think a lot of work has to be done by the government, in terms of educating also the people of India. So infrastructure, money, education, plus focused on industries that want to really that India can actually do in the next 5 years. Start, seeding the OSATs, and also maybe a 28 nanometer fab, at least 1 or 2 fabs in the next 5 years would be significant.
Great. Thank you, Mr. Vaidya. Let me get into now what we call as the open questions, for any of the panelists to pick up an answer. If I hear silence, maybe I'll call out names. But here's the first one. So let's, taking from the point of the $10 billion may not be enough point of view, especially if you have to cater to all of these display fabs, for example. I don't know if any of the panelists would like to throw a number of what it might cost to even set up a minimum level display fab. Now, if that is the case, what do we expect? Is this $10 billion going to be the overlay only from the central government? Is there going to be more money from the state government? What is it going to be looking like? I am told that the details are going to come out soon, but we don't have them yet, possibly. So anybody would like to throw, and in case this is it, if in case this is $10 billion is it for now, what is going to be the next step that the government of India has to look into? Anyone? Would
Nisha may be the best
yeah, would
person. She
Nisha
has a powerful expert.
want to take it maybe, or yeah?
Oh, yeah. Thanks, Arun. So I think the states definitely have to come in because I mean, as the other panelists have mentioned, this is not going to be enough to set up the whole ecosystem that we envision. This is a good starting point. It was much needed, and we're glad that it is coming in. But the states have to set up. We're also seeing a trend. If you look at the macroeconomic setup of India, we're seeing a trend where the states are starting to spend more than the center, right? And so, especially individual states like Maharashtra, Karnataka, Gujarat, UP, the top five, they have tremendous potential because they also have the human capital required, as well as they have higher tax revenue generation coming in. They have all these factors that can help in setting up these fabs. So if the states now start putting their best step forward and include incentives along with the central government mandate, I think that will be phenomenal for India because that we can even look at doubling this 10 billion very quickly with the state input. The other component, of course, is we have to start looking at beyond urban. So unfortunately, India's industry setup itself is not as well utilized as it can be because we tend to structure it all around our urban conglomerates. Living costs and labor costs are skyrocketing in your tier one cities, and so we have to start looking at beyond urban and start placing these fabs and other manufacturing outside urban cities. So how states start structuring that to drive costs down and then bring their best incentives forward will also be very important in a volumes play like semiconductor will be. I know now we're talking about a couple of fabs, but then we start going into design and then verification and then fabless, and then there's tremendous opportunity here to set up volumes of companies. And so that's where I think the state intervention will start becoming very important. Again, especially in states like Karnataka and Maharashtra that already have the human capital. Bangalore alone has 300 plus design companies. Most of them MNCs, I know, but at least the human capital is there. Industry veterans are starting to move out of structured companies and starting their own enterprises. More entrepreneurship is coming in, and so if states also start incentivizing, this momentum, I think that'll be significant for sure.
Excellent, thank you. Anyone else would like to add on to it?
Yeah, let me add, Arun, Sandeep here.
Sure.
I think this is, we have to look at it. See, as you yourself said, many details are yet to come, and instead of guessing, let's wait for the details to come in. But like all other incentive schemes, states do play a major role, in attracting investments, and some states are more forward-looking than others. And I think there is a good, healthy competition going on among states to attract investments, which is a very good thing. And I think what everybody said, this is not enough. Let me emphasize that I think this ecosystem will develop. It will take time. What was needed was a big, heavy start, and that has been made with this announcement. And I think now the entire universe, the entire global ecosystem knows that India is serious about this intention. And I think they will look at India as a destination with a very different view, with a very different lens. And that is what is needed. That is what was needed. And when they start looking at India with a very different lens, different things happen. So I think as things progress, I'm sure what we have seen with the government in the past few years is that they are very open to ideas, suggestions, and when things start to progress, and if there are new suggestions to boost the framework further, I am sure they will take it up absolutely.
Excellent. Let's look forward for that. I think Professor Subbu probably may have to leave in about 15 minutes or so. So let me throw the next question to him, which is also coming from the audience, and this is about three fives. I think it's specifically GAN and gas. So yeah, and what is the significance of the defense sector? And maybe let me add my own little piece of to the puzzle. The government says at least 15 in the segment of compound semiconductor slash silicon photonics slash sensors, including MEMS slash OSAT. Let's give three each to each of these segments. What do you think is the total investment? I'm not talking about investment. The total investment, whether be it private or government, that would be needed for 15 such companies.
That's a lot. Yeah, so I think again, right, one has to think again of how you want to slice this, right? So let's take a 3-5 company. Unfortunately or fortunately, the menu of 3-5 materials and stuff like that is so rich compared to silicon, right? In silicon, you have just silicon, but for 3-5s, you have gallium nitride, you have indium phosphide, you have gallium arsenide, and so on and so forth, right? So you have to actually figure out which one you want to hit, right? And so once again, right, each of these is going to cost very similar numbers to a fab. So for example, if you say, okay, I want to address gallium nitride because power is a big issue in India and we need to make our own power ICs and stuff like that. Okay, gallium nitride is a good choice. If it is high bandwidth communication, maybe indium phosphide is a choice. Somebody needs to understand strategically what is more important. My gut feeling is, based on what I know so far, is that the cost for a 3-5 fab, if you say that a 28 nanometer fab, like we talked about, is somewhere around 6 to 7 billion dollars, the cost of a 3-5 fab is about $3 to $4 billion. Okay, because the volumes are not necessarily the same. There's also another issue, and that is the material, right? If you are saying that I'm going to grow my own material, grow my own 3-5 materials, that is also a fairly big one. But presumably, at least initially, one can buy this material, though unfortunately, the biggest source of the 3-5 materials today is actually China, right? So we have a small project in our lab on LEDs, and we cannot buy, say blue LEDs and green LEDs in the US directly. We have to buy these wafers from Chinese manufacturers, right? And the Chinese manufacturers obviously sell it quite cheap. But again, if it is strategic, right, this is going to be an issue. So I think, we have to think through that very carefully and make sure that the supply chain for these 3-5 materials, if you're going to go into the 3-5 materials, is secure, right? And that if you want to actually build your own supply chain for these materials, you should add at least another $1 billion and make sure you have the infrastructure to do it. So we're talking about 4 billion. So if you say 6 billion for the 28 nanometer fab and 4 billion for a 3-5 fab, the OSAT fab is probably the cheapest of them because you can actually size it appropriately, and maybe you need about 500-600 million dollars to do that. So right there, right, with these three things, you hit the $10 billion mark. Let's assume that you get sort of equal investment from states and private industry, right? I think that will go more into developing the infrastructure and ecosystem that is needed to maintain these fabs. Remember, it's not just a question of setting up the fab, okay? I think what people don't realize is that maintaining a fab, okay, spare parts, and my good colleague from TEL probably will tell you this, right? The where TEL makes its most money is not selling you the initial equipment; it's actually selling you the services. And so you should definitely budget somewhere about 20 to 25% per annum of your capital outlay for maintenance. So if you say that I'm investing, say, 10 billion directly, okay, then you should have roughly $200 million a year, okay, 200 to $250 million a year just for maintenance and keep this thing running. Okay, and this is something that we never really pay attention to, even in the US, right? People will start new projects and fabs and so on and so forth, and then they get a big shock when they find out that the tools went down and it's going to cost them a tidy sum to fix them and repair them and keep them running. Okay, so this is also another aspect that one needs to consider. Arun, I don't know if I answered your question.
Yes, fairly. There are probably a bit more specifics that I can probably connect with you later and understand. So let me again, since you mentioned about the the fab costs and so on and the maintenance cost, for example, I probably want to throw one specific question again to Mr. Vaidya, and then I have a bouquet of questions for all the panelists. I believe Nisha also probably have to leave in about 15-20 minutes. Mr. Vaidya, quickly, the Japan, what we hear about the $7 billion fab coming up in Japan, with TSMC putting in a little bit, the government we hear is putting in 50% of that. Agreed, Japan already has an ecosystem. It already has that probably up to 40 nanometers technology there. But is that, along that model is something even possible in India? And if I understand it right, the overall money that Japan has put into for semiconductors as incentives is not as big as $10 billion that India has put in. But they've been very specific in terms of putting that money into one particular project. So, what are your thoughts on that? Is that a model workable for India, or is India doing the right thing right now by possibly spreading it across more?
I think the Japan model wouldn't work for India for a couple of reasons. One, Japan is trying to, the most important, one of the most important objectives they're trying to ease out is the supply chain. Automotive, it's their biggest, one of their biggest sector. So Japan is trying to ease the pain around automotive. They're working around that. Plus, in the Sony CMOS is the Sony already has technology. It's not that Sony doesn't have technology. Sony is a good technology partner. They have the infrastructure. They have both the engineering skill sets, the 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 hard physical infrastructure. So it would be significantly less challenging for a company like TSMC to come and set up in Japan. There's already a pool of engineers, infrastructure, even technology is available. So there's a piece of technology that TSMC brings in terms of logic technology, but pretty much it's going to be captive within Sony. So Sony is just going to take it and package it and sell mostly CMOS. They're going to combine the CMOS logic piece of it. So there's also some kind of a benefit for TSMC also to work with Sony in terms of working as a customer in terms of captive packaging. So the same model doesn't apply to India. The motivation factors are different. The existing infrastructure factors, it's much easier to make a decision to come into Japan and set up, like for example, TSMC going into Arizona. There are some challenges there, but still it's significantly lower than say India. India model should be based around somewhat close to what China did, but accelerating. Also, I should say that like it took probably Taiwan maybe 20, 25 years to be there where they are today. Korea took longer time. China took significantly, probably lesser time, maybe half. It's probably a decade of acceleration. They did set up fabs in 2001, 2002, but it was dormant because of the restrictive US restrictions. US lifted the restrictions only around 2008, 2009. So, if you look at from that time frame, they had a significant acceleration of their industry. So if China takes maybe 10 years, India should look at least 7, 8 years, but around the same impetus in terms of both money and focus. There was a significant focus from the highest authorities of government in China, huge investments, and there was also in terms of not just local infrastructure, they went and sought engineers everywhere in the world. They paid them top dollars to come and set up in China. So if India has to follow a model, the recent model that India has to follow is China, in terms of money and in terms of their infrastructure setup. I think we need to copy theirs. That'll be the closest. I would say a successful one. Yeah.
All right. So what we'll do in the interest of time is we'll have it running for 10 more minutes. I hope all of you can stay back. And I'll throw a bunch of questions one after the other, and you pick and choose. So this is a question on what are possibly going to be the kind of incentives for the design companies. There are questions on how do we make sure that all this investment are not going to end up in some sort of failure. Investment are in incentives. I'm not talking just about design or anything, but everything. There's question on what is going to be the future of SCL, given that government has put out interest for a joint venture. There is a question on what is the government targeting? Are the chips that are going to be made in India only for domestic use or also for exports? And there are also questions on what about the private players, the Tatas and the, you know, Ambanis, or name it, Adanis, and any other private companies. Is the government going to engage with them, or are they already, and are they going to get into these spaces? So I think I threw 5 questions. Please pick and choose. Who would like to go first?
I think Arun, let me, besides these questions, I think some of them we will get answers, as the time goes by, details of the incentives and stuff like that. But I think fundamentally, one thing which comes to mind is that this is an opportunity for us to build a complete supply chain ecosystem. And I think if you look broadly for the industry, I think the main segments which comprise the supply chain for semiconductors is the equipments required for manufacturing, the materials, chemicals, minerals, gases, uh, and then services and testing, marking, packaging, etc. Right. So I think within these, if you look at numbers, these 3 main segments uh, of the supply chain, they account for about 220 to $30 billion of business right now, and which can go up to $540 billion by 2030. And I think what we need to figure out is that how do we make sure that we at least get a 15-20% share of this ecosystem? And I think that is what this whole policy might enable if all goes well. I think this is a great start, as I said earlier, that we need to put ourselves in the middle of the things and not just be content with building a few fabs. We need to make sure that we are in the middle of things and we are an integral part of the global supply chain ecosystem so that we are not left behind in any which way.
Great, thank you. Anyone else would like to add on to that or pick another question that I threw, or probably have on another 7 minutes?
If I
Sure,
may,
Hi.
Arun, I mean, before I leave.
Okay, so I think we'll have Professor Subbu
Yeah.
talk first, and then Nisha.
Yeah, I think
Sounds
the
good.
argument that we should somehow be part of the global chain is actually very, very important. And I think trying to figure out where you fit into that global chain is also another very big issue that needs to be addressed. And how it aligns with our own strategic interests is equally important. In other words, we don't want to be in the global ecosystem if it does not serve our own needs. So if we decide that communication chips are going to be our sort of strategic investment, then how do we become a key player globally in communication chips? So again, right, all this requires very, very serious technical sort of discussion and also marketplace understanding of how the market is evolving and so on and so forth. So it's very important. But I think more getting into the global supply chain is important, but supplying the Indian needs is actually even more important.
Nisha, you wanted to add?
Great. Just to add to what Professor Subbu and Sandeep sir were saying, we have to look at it from a 20, 30-year forecast at least, if not more. And the government is great at doing this. You can see that with several initiatives, right? With the pharma initiative, right now India is one of the largest manufacturers of vaccines, and that helped us during COVID. We've seen this with India's push towards 5G and communication networks of the future. And we also want to see this forward looking policy making in this ecosystem, because as both the panelists said, it's the semiconductor is not just about fabs. So there's just to quickly go into this, there's design, and then there's a verification layer, and then there's fabs or fabless, right? And so beyond fab, now it's great that the government has put its best step forward. It's going government to government first, and it's inviting these JVs that our private companies can have with private companies from other countries. And so it's having fabs is all about securing our supply chains. But then if we look at the other layers, the design layer and the verification layer, India already has a huge advantage there, right? India is possibly among the top five in design, because every large semiconductor company has design talent in India. You have the Qualcomms and the Intels and Samsung and so on and so forth. So we also have to incentivize those players to build for India more, right? So government has to channel more capital here. We have the verification layer. Almost all the verification in the world goes through India today. We are among the top three, and so there again is a huge market opportunity. And then the third opportunity beyond fabs is going fabless. Because if you look at ARM, which is I think a $10 billion company today, it is fabless, but its chips are in every smartphone today. So that's another big opportunity. India needs maybe 10 arms, 100 arms to capture this global supply chain and be an integral part of it. And so these are different ways to start thinking about getting into the global supply chain, as Sandeep sir said. And so we have to start thinking about this, right? Now, the other, you mentioned our private companies like Tata, for example. I was very happy to see that Tata is going forward with their deal with TSMC, because, communication networks was something mentioned by Professor Subbu. Tata has made a very strategic investment by acquiring Tejas Networks. Tejas Networks is very well entrenched in communication architectures. So that is the strategic steps India needs to take by channeling such companies into specific ventures like communication networks. So Tata can use the fact that they've acquired Tejas, and then maybe even go fabless to build the intellectual property pipeline around communication networks, because that is as important as the fab component today. The intellectual property around the design and the verification and the chipsets and the and all these different layers. So that is the Indian ecosystem. And as we've mentioned in the introduction, India it has a very large market opportunity. It's one of the biggest markets out there, and the install bases that we need for semiconductor chips are huge. It's a huge opportunity. Our Prime Minister has committed to ESG, responsible environmental, social, and governance initiatives. And so, everything is smart now. You need the smart grid, you need IoT, EVs, so on and so forth. So it's a very big market. And so there's all these different strategies that India has to deploy to get into the global supply chain and to capture this market, not only for our domestic consumption, but for exports as well. And so that is why I think this is a good step. And there are all these other initiatives, and there are many entrepreneurs that can use the capital that the government can start infusing into the ecosystem.
Excellent. Thank you. So I think one final question, and this probably goes to Vaidya. Well, maybe two questions to Vaidya. First is, 8 to 10 year plan for fabs to set up and be in production and so on and so forth. When can we possibly see equipment manufacturers setting up not just support but actual factories in India? And two, the question about SCL that I asked before to either Mr. Vaidya or anybody on the panel, do we see a plan in place for the SCL in Mohali?
Okay. So let me answer the first part of the question. In terms of fab equipment manufacturers setting up fabs outside their home base, of course, Applied Materials and Lammus, they've already done that. There's a significant increase in production requirement in the last 5 years or so. It's almost more than triple. It's like for 4 to 5 times the size of what it was like 6-7 years ago. So it's a significant increase. And with the market growing, and let's say India comes on board, there'll be a significant in terms of capacity requirement for equipment. And there is a high chance, maybe 10 years from now, that an equipment manufacturer will open up a base in India. India has a talent base. And it's both in terms of designing equipments, and also in terms of the IT and also the industry itself is moving towards more from mechanical to more software related content. So India will be perfectly suited for this transition. So there is a very high chance that the industry might look at India as a manufacturing base in the future, maybe 10 years from now, for sure. But as for the base now, TEL is not there, but Lam and Applied is already using India as a base. India has significant talent in terms of IT, AI, data sciences for the future. So there's a tremendous potential for India to be a player in equipment, part of the equipment manufacturing world. Yes.
Thank you, Mr. Vaidya. Anyone taking the SEL question? Not yet?
So I don't.
Sure,
I
please.
I can take a stab at that. Now, SEL specifically, we'll have to wait for details, but I'm always in support of these JVs between private companies and public research institutions.
I think Nisha was on. This is why we need a communication
Research
chip in India.
institutions and which then they come out with significant technologies that have a bearing both on civilian use and commercial use, as well as national and military use, right? And that is why initiatives like the SEL become very important, because when you use these JVs and these partnerships to develop cutting edge technology, it is then both the purview of the commercial sector as well as the public sector. And so both these dual use technologies can come out significantly out of JVs like that. And so I, for one, I'm very interested to see what they're going to do with the SEL. And hopefully India starts pioneering more of these dual use technologies. Semiconductors obviously has become so integral to our lives that it'll be useful to have a dual use model in this space in India, for sure.
Great. I think, as a matter of coincidence or whatnot, I should probably say we have some breaking news that the Gazette notification has just come out with details of some of these policies. I thought I could sleep, but maybe not. But any case, and Professor Subbu might have left. He just messaged me. I'd like to thank you all, all the panelists that have attended and shared your wonderful insights. I would like to thank the team at Swarajya who has worked behind the scenes and made this happen, and most importantly, the viewers. As you all said, this is just a start. This discussion was just meant to be a thought starter, and it probably just ended with the details. I don't know to what extent, but some details of the policy coming out. So it's definitely a good start, and let us look forward for more discussions, more brainstorming, and making a real change of this happen. So thank you once again. Good night or good day, depending on where you are. Thank you, viewers, and we shall close now. Jai Hind.